As you can see by my cool little cat and mouse, just before we go into what the plan is today, everything we do here is a never-ending cat and mouse chase. Anything attackers do, application developers evolve. Everything application developers do, attackers evolve. So we're going to learn a bit about APKs, which is that final application or big binary you have after you've finished an application. We're going to look at some really common reverse engineering techniques. Going to look at some real-life applications, the ones in that top 10, top 15 Play Store, and then look at things Android has done to help, and then just random custom tips we can do as app developers along the way. So then why is it me? Why is it this weird dude up here talking to you about this? I'm Connor Tumbleson. I'm a senior software engineer at SourceToad. We're also a sponsor, so yay work. And I'm also the maintainer of APK tool. You may have heard of it, you may have not. Hopefully by the end of this talk you'll know what it is. It's, we'll get into more what it is when we get to that slide. So today we're going to learn what is an APK. I mean, you know what it is in the source form when you're building an application, but what is it after it's compiled? We're going to look at some tools. One of my feedback at my last talks was I skipped steps between what we did. So this time I'm going to explain the middle steps, which involves what tools I used. And then we're going to extract some things, whether it's business logic in an application or the assets. And we're also going to rebuild an application because a lot of attacks you can do by just simply reverse engineering, changing something, and then rebuilding it. So if you know, or if you don't know, an APK is just a jar file, and a jar file is just a zip file. So you can unzip an APK with just a basic tool, and you're going to get something that looks like this. All we really want to do is look at those files at the end, and we can ignore all the output of the tool, but you can see Android manifest.xml, classes dex, and a resources.arsc file. Those are the only ones we really care about for this talk. Everything else in there you can see just things we're not going to talk about today. And if you thought, hey, an XML file, yay, let's go look at it and see what's in it, you're going to see, well, strings, the layouts and the images that are in your application. You just worked with it maybe if you were developing an app. Likewise, the DEX files, we just had a ton of cool talks today about Kotlin, but what Kotlin does is it still builds down to DEX files, the same thing that Java does. So regardless of what you develop in, you're still getting a DEX file. And then shared object files, those .sos, those are native things. So libraries, game engines, or if you're writing any of your code in C++ in your app. So if you thought you were a funny guy to open the XML file after you unzip the application, you're going to get something like this. Not very readable at all. But you can actually tell towards the end of the file you're getting some human readable text. You can see like some property names for SDK version and stuff, but this is not readable in any way, shape, or form. Thankfully, there is a tool that can help with this, and more personal advertising, cool little logo. I think I put some stickers around. Is APK tool. So what APK tool does is it's going to disassemble the application. Take that, what we just looked at prior here, if I back up, where it's going to take this serialized XML and unserialize it back to a human readable form. So we're going to go from that to this. And you can see immediately we know what we're looking at. Now, I didn't make Snapchat, so there's no reason why I should have this file on my computer, but disassembly, there it is. There's their manifest file. You can see there's their package name, com, Snapchat, Android, all their mumbo jumbo platform versions, installs, and all their permissions. This file is actually a lot larger, but for the sake of putting it on a slide, I just snipped the top. You can see, there we go. We have everything we need to know of their manifest, which a lot of reverse engineers start here, because this exposes all your intents, activities, and you can see quickly where to go from there, or where to pivot you're looking. So, like I said, I'm going to go into details of tools along the way on this little journey. So this is, I'll say my tool now. In 2010, I took it over from a guy named Brute All. He's a pretty smart guy from Poland. He now works at Samsung. In 2010, shortly after Gingerbread, he had to give it up. He never said why. I think it was some legal reason. I really don't know why. but he passed it on, and I took it over then, and now it's been 7 years now of maintaining it through every new Android version and every new OEM that tries to break it. It's too much for one person, hence why I put those stickers everywhere for more contributors. So hopefully that will help out. But at the core, it disassembles source, which actually uses another great project called Somali. If you're around in that Android community, his name is Ben Groover, or Jesus Freak is his online alias. And we can also rebuild applications, which makes this tool very powerful. It's open source. We're coming up where we passed 6 million downloads. Since Bitbucket and GitHub had download counters, removed them, only put them in the API, it's hard to really know how many downloads there are these days. So I don't know. And funny side story, Bitbucket actually lost all the downloads in our project and had to start it over. So all of our download counts went from 200,000 to 0. Not something that really matters that much, but it was maddening to see. And then another side thing about Bitbucket is we were the target of a pretty bad vulnerability. Someone maliciously uploaded files to a repo. I have two-factor auth. My account was never touched, but someone got to upload files into my repo, which was a pretty bad vulnerability. So they sent me a bunch of shirts and said they were sorry. So we're going to look at 3 attacks here with the cool little creepy attacker guy. Network attacks, man in the middle if you don't know what that stands for, and proxying, basically just trapping network traffic as it goes from client to server. And then source attacks, really what we're going to use APK tool for. If you can decode an application and change something and rebuild it, you can get it to execute. So you can just change the application. And then finally, hook attacks. These are probably the coolest ones and the ones that you're going to use in this day and age. This is exposed. Substrate is not really used anymore. That was made by the same guy that made Cydia, or on the iOS side. So a nice little family of tools. So we're going to jump right into it. This is a tool we'll talk about soon, but I'm just listing everything my phone is doing when I open an app. And here, I don't think you can tell by these ugly URLs, but this is Clash of Clans. I've never played the game, so I really have no idea what it does or what it's about, but I went to the top 10 free games with that you can also buy things from. I forgot what that category is called. Yes, and then I just started looking at the network. You can't tell from this screen, but I immediately was laughing at them because what we'll see right here, tool, talk about it real quick. This is Charles Proxy. It's pretty sweet in that it shows you everything that's going on. You can see the size of the request and whether it failed or not. It, unfortunately, though, costs money. So if you're in that market of I don't want to buy anything, stick with Fiddler. But the more and more you do stuff like this, you need things that have a bit more feature set. So Charles is where I stick. So this is why I said this one was pretty embarrassing. It actually doesn't use SSL. So we'll jump back real quick to look at all these CSV files being downloaded. Not a single one of them is over SSL, which means the contents of the request, I don't need anything special to look at. Just simply acting as a proxy in between, I can download the CSV file. Now, you might be saying, well, okay, you can view the CSV file of Clash of Clans. What the heck does that matter? For a lot of things, this, regardless of the app at hand, sometimes viewing the CSVs that applications are downloading is a pretty serious thing. But I opened the CSV and once again, I have no idea what this is. This is not a CSV file. So what do we do? For an application that didn't even use SSL, I don't think this is encryption. So my first thought in my head is compression. In the pool of things, it's compression, encryption, or some ugly mix of the two. So now that I, in my head, think there's no way a company doesn't use SSLs using encryption, I'm going to start looking into compression. In the family of compressions, there's only a few of them actually used, even though there's probably hundreds. There's only a few main ones, and that's like gzip, LZMA, and Z. Some of these are proprietary, some aren't. So now in my head, I'm thinking, I want to decode this messy blob of text. What do I do with it? Well, I also have the application. So why don't I just start looking at the application and figure out, hey, can I see how it's decoding the CSV to see what it's using? So I use another tool that I love that we're going to look at with the tool slide right after this, but I just start typing in Z, LZMA, gzip, etc., trying to pull strings from the application and figure out which one it's using. After typing in all these, I finally got success on LZMA. I'm getting a bunch of hits of like the decompression and especially like the initialization of some things. So I know now, or best guess, that they're using LZMA. So tool, that was Binary Ninja. It's a pretty cheap reverse engineering platform. The other alternative in this family is IDA Pro, which $2,000, $3,000. It's pretty expensive. This was $199, so it's pretty cheap. You can also go free with Radar, but some of these free alternatives in this family of reverse engineering is just not good, because this gives you strings disassembly and you have a full Python scripting library at your hand to write what you need. So there's also another sweet tool called binwalk, and it actually will take a file and crawl it looking for magic, and magic is those like first few bytes of a file that tells you what it is. Like a JPEG is famously JF something and PNG is PN something. It's easy to detect what a file is by its magic, those first few bytes of the file. So binwalk just climbs a file looking for it to identify things. And you can see the first run here, it actually didn't detect anything, but the second time it did. The steps in between there I'm going to go into right after this, but you can see after I did these steps, it was successful and it found some LZMA compressed data. So what the steps were in between here, I'll say binwalk, sweet. It is what, as I just said, like identifying those the magic blocks at the front of a file and how to identify them. You can see it just takes a bin image here. Like this time they're using an image from like a firmware, and it's just dumping out everything it sees. In the case of what we dealt with here is I knew it was LZMA, but binwalk wasn't detecting it. So that meant it had to be a tweaked LZMA header. So what I did was, it was pretty ugly. I opened up the LZMA spec sheet, looked at it, and then looked at what I was looking at in a hex editor and realized, oh, they are missing some bytes in this header. They're probably modifying it to break tools, because no one's going to rewrite LZMA. They're going to use it, but they might tweak the header to throw off reverse engineers. So I looked at the header and I was like, okay, they're missing 4 bytes. This is child's play. And I just added in 4 bytes and ran the command right here again until it detected it. And after that, boom, I have a CSV. The CSV is actually huge. There's like 90 columns in it and a ton of data. I don't know really at all what it means, but I have all these columns and fields of data, and I have all the CSVs now. What I do for this for other games, and not this one really, is once you decode the CSVs or whatever, you have the exact values of a game. You can do formulas, guides, scripting. You can build a lot now that you know the real values of something. And now anytime this updates, or the best thing is there was apparently like the launch of a new level or something in this game, but the CSVs had it 3 weeks before they announced it. So you know what's coming before they announce it. So you kind of destroy their, big announcement, because they put in the APK without telling anyone. But games, this one's boring. There's a more fun topic of Snapchat. Everyone I think knows what this is. If you don't, you send an image, it disappears. It's supposed to be like private image sending. You send it to someone and after a few seconds it disappears, presumably forever. And during transport of these images, they're encrypted. So even if someone's sitting in between you and the other person, they're just going to be a big encrypted blob of text and not be able to do anything with it. Unless, thankfully, my last bullet point, you know how to decrypt the images. So this is very bad and embarrassing. Way back in 2013 when we started looking at Snapchat, they had 2 keys hidden in their application. And this is Somali view. We're going to go into how to read this later on. So for now, just look at the arrows and look at the raw text. You can see right below these lines, they're actually labeled AES encrypt keys, 1 and 2. And we'll go into the encryption, which AES it is, right after this. But their keys are hard-coded in their application in 2013. So this meant not even that if I send an image to someone, it's decoded, it's using the same key that everyone else is. So if you had a device and you just wanted to view their encrypted images, just dump the images from their phone and decrypt them. Once they view them, they're gone, so that wouldn't work, but I mean unviewed downloaded images that are just waiting in cold storage. So this actually was ASCEB, which is electronic code block or book. And we saw a hard-coded key. And what's funny enough is in all the testing I did, the other one in this file that we saw back here, encrypt key 1 or the one not labeled, was never used. So I don't know why there's 2 keys in the file. It had to be some staging versus production environment. Yeah. So they never used it, which meant there was only one key, this MO2CN1. And it's funny enough, if you just search the first few letters of that on Google, you'll find it everywhere. People found this out pretty quickly and made fun of Snapchat for it. So I like going into what some of these ciphers are and how to understand them. And if you don't know what it means, then just this little image right here should help explain it. If you have your plain text, whatever it is, you have a key, which means the same plain text with this key equals the ciphertext. And that's all this basic thing is. I wish I had put an image up here to show you, but if you were to take an image and AES it, you'll see the same type of image. It will be encrypted, but you can see the outline, which is, this was not a good pick for image security at all. We saw in 2014 Snapchat updated. It changed to something else, but it was weird. What they did was a combination of your Android ID and the string seems legit compounded together. Now, I don't mean literally the text Android ID. That is the value of your phone, the Android ID, which is unique per phone, but changed a lot in Oreo, which we'll talk about when we get there. But the point was, hey, we're not going to use a hard-coded key anymore. We're going to use a per-device key. The unfortunate thing about Android ID in 2014 is every app gets the same Android ID on the device, that is. So even if I have these images in cold storage, it just takes one malicious app to pull them out of storage and pull the Android ID, compound it with seems legit, boom, your images are decrypted once again. So right after this, they introduced a file called a banana file. I don't know why they called it. These developers are pretty funny with the strings they use. They started upgrading to a new form of AES, which is CBC. And now they took these compounded Android ID and seems legit and used those, this combination of encryption on that file and started using random keys and IVs, which we'll talk about here, on the AES CBC side. And if you don't know, it's cipher block chaining, and the idea is to chain each block together so each one is dependent on the prior block. But then you're imagining, oh, then what is the first block dependent on if everyone depends on one? Well, that's where your IV comes in, your initialization vector. So now Snapchat in 2014, we're pretty good. We have an app that generates random IVs and keys for every image and stores them in a file called bananas for some reason. And that file, however, is another thing that's encrypted with static information, Android ID and seems legit. So all you have to do now in 2014 is get this file, decode it with that, and you have all the keys and IVs of all the images you haven't viewed in Snapchat yet. So once again, useless. You can view all private images. After this point in 2014, I stopped looking at Snapchat. Life priorities changed, and I never bothered to look back into it, so I have no idea what they're doing now. They could still be doing this. It's not something I've dove into anymore, but I only like looking at applications and watching them grow for a certain point, and then the time and effort to look into them for one guy just becomes too much. So they've definitely learned, and I'm sure with the funding they have now that things are better, but that was just a look at back then. Here's what I said again about CBC. You can see every block is dependent on the previous, and for the first one we have a nice little IV for the initialization vector. Now we're going to talk about some fun things. Man in the middle, or what we were just talking about, MITM. The idea is that between your connection with the server, someone is sitting in the middle, proxying it, but also being able to decrypt it. And how they do that is they say, hey, trust this certificate that I'm giving you, please use it. It's a trusted certificate that I know the private key to, which means I can decrypt the traffic. Usually people are man-in-the-middle attack themselves. It seems weird that it's depicted as another person. I man-in-the-middle attack myself in order to decrypt traffic that I'm using. It's mainly so I can see how an app is communicating with its server. I want to know what's going on. So I wanted to try Snapchat. So I tried to sign up a new account because I don't want to man-in-the-middle attack my main account because people can detect this kind of thing and I might get a nice ban. So don't want to do that to my main. So started a new account. Immediately I was blocked. No matter how many times I tried to sign in, I just kept getting failed to connect to server, failed to connect to server. And I could see this in my tool, Charles, that it was just saying failed, failed, failed. So they were rejecting my request because I had a certificate that wasn't trusted. It was just a certificate I generated through Charles that I obviously knew the private key to. So onward to door 2. What can we do now to figure out a way to man-in-the-middle attack Snapchat? You can see when I was trying to figure out why this wasn't working is I just dumped the logcat from Android, and you can see it's dumping out. This is like a hash of the key for whatever Snapchat is expecting. It's pinging snapchat.com, obviously a website they control, to see, hey, connect to this website. We know what public key we're expecting to get. Let's see if we get it. And you can see I failed the check. Success, false, failed host. I didn't, so that's probably why they rejected me. So this means SSL pinning is in play, which enforces the fact that I can't use a bogus certificate. And it's a very powerful, but also risky thing to do. A lot of applications in the past have made the mistake of implementing SSL pinning, but then the renewal date of their certificate comes up and they never push that new key into their application. And then you have this time where you're waiting on app stores to update for your app to work again, which has happened a few times. I don't remember who it was, but this is happening, that people aren't taking the proper fixes when SSL pinning. And the last note here is what to pin. If you don't know like how the hierarchy of certificates work, the leaf certificate is the one you have, the really specific one. And then you get that obviously from someone who provides you your SSL certificate, which is Let's Encrypt or the paid ones. And that's the intermediate. And then the real certificates are those huge root trust stores that there's only 100 or so out there. So you can pin any part, any level of that. If you pin the leaf, it's very secure because you know you have generated the certificate. You're asking your consumer, your client, to connect with it. If you do intermediate, that's like saying, I'm going to trust Let's Encrypt, which is fine, but a lot of people can generate certs on Let's Encrypt, so it's not exactly the most secure. And then root pinning, that I don't know of anyone who's really doing that, but put it up there. So my next idea was, hey, I want to figure out how I can man-in-the-middle attack this. What can I do? So the more and more you work with Java, the more and more you just have things memorized of how you handle things like this. And I know that's from the X509 certificate, which is like the standard for public keys. So all I did was check the 2 methods that I know this interface has, which is check client trusted and check server trusted. And I did this in my decoded Snapchat folder, which is what I used APK tool for a couple slides back. And you can see I'm getting a lot of hits here of the methods. And you can see actually in the beginning before it ran, it told us 3 DEX files, 6, 5, and 4, had this code in it. And you might be wondering, hey, why is there 6 DEX files up there? Well, we had a point in Android where you could only have so many methods in in your application without exceeding the maximum methods that a DEX file could hold, because they unfortunately only made that whatever that data column is that stores it. It was a short, unsigned, so 65,000 something was the only maximum methods you could have. So then we entered the wave of DEX files that could load others. Like Facebook started writing this weird code that would download DEX files on runtime, which is why people run Facebook Lite now, because that application is a massive hog that downloads like 10 DEX files and then runs them. It's not cool. Now, however, there's like an official way to do this through Android. I'm blanking what it's called. Multi-dex might be it, and it's an official way. It's a lot easier, and it does what you see here. It just appends on a number and just keeps adding dex files to your application. But that out of the way, you can see we have in classes 4, 6, and 6 places that we need to patch. And now we're going to jump into Smalley and take a look at understanding this. This is Smalley. It looks like Jasmine if you've ever written in that. It's pretty easy to read. If you've never looked at Smalley, I'm sure you can understand what's going on here in 30 seconds. We have the method name, and then right here with the parameters we have, it's accepting a certificate and a string. And that little v at the very end is what it is, and it's a void. Okay, so looking at the Smalley up here, we see two parameters, a certificate and a string, and it's a void. And if you know what a void is, that means you're returning nothing. You're not returning a string int Boolean. You're just running code, and when it's done, you're done. So I thought it would be really funny here and just add one line into the execution, return void. I don't want to execute this interface down here that's going to run the actual checking. So I'm just going to return early, and I was like, that should work. And I ended up patching all the methods we saw on that line before. And I thought I did it. I started getting the request in. Wow, that looks weird. Have they always looked like that? Okay. I got through. I got one request through, but then Snapchat blocked me again. It said, oh no, your temporary failed, try again. If you click that link in there, it actually leads you to a page that says don't use third-party apps, which was strange. Even though I was using the official app, they detected that I wasn't. It was the official app with some changes, but it wasn't official. I was like, wow, how did they do that? This wasn't Google Safety Net, if you've heard of that, because it's pretty easy to detect when that's running. So they had some sort of code that was running checksums and verifications on their own app, which was very cool, which blocked me again. So I went to my final door 3 for this, and looked into my next task, which was exposed. And exposed is great. It runs on top of your system, which allows you to hook code instead of modifying it. So I can write hook events that's waiting for whatever's running on Snapchat and do it that way. Unfortunately, I need root for this. And with the rise of things that are blocking root, it's a challenge now to root myself to do this. And until about 2 weeks ago, Expose didn't exist on Android 7, and definitely doesn't exist yet for Oreo. So it's tough. Android is trying to actively block it, but it's actively trying to exist. Thankfully, though, you can just downgrade. No one's telling you you have to be on these new Android versions. As we saw in whatever talk it was today, KitKat is still very popular. We can downgrade very far and still have success. So that's what I did. I took my dev device and downgraded a bit, and I was back. I used an expose module. I didn't write one. For the sake of time, I just said, hey, there's got to be a Snapchat module for expose that does what I need, and it does. It allowed inspecting the traffic and using it. Unfortunately, though, I couldn't upgrade to the newest Android. I was stuck on an old one with this. And you can see I logged in. There's my fake account. What I thought was pretty funny, and you'll never notice, is I actually put fake black dots and erased some of them on that image, so don't try and add it. It's not going to work. So we'll just talk about then Android 7 real quick. Is they added an amazing thing called the network security config. And this allows you, without any effort, to just put this file. Well, you have to change some of it. It's not that easy. But you now have full control over pinning in your application without much effort. And this allows you to say, hey, I'm only going to trust the certificates that are on my system. And there's a big difference between system certificates and user certificates. On my Android device, I have like 2 user certificates, the ones that I want so I can decrypt traffic. If I were trying to use an app that had that set up right there, it would not work because it wouldn't parse my user certificates, which is great. It's a great feature. However, once again, like all Android features, it's not going to work until everyone's on 7. And we're probably years away from that. If you are new, though, you can leverage it. If you're not, well, it's a constant battle. You can stay on KitKat and use exposed, come to the newest Android and get security fixes. You can't win until until everyone's on it as an app developer. And there was a huge, huge change in Android 7 called the signature scheme, v2. If you don't know, in KitKat, you could actually take an application, modify a file in it, and push that application back to your phone, and it would run it. The only files that you weren't allowed to modify were the Android manifest and anything in that cert folder with a meta inf. Now, how that worked, that shouldn't have worked ever, but it did. After KitKat, they did patch that, so you couldn't do it anymore, but that's, again, why people are using old Android. And one big thing to note is you control your Android device. I easily can rebuild my system to not check applications. The code, I own the phone, which people sometimes forget when they're developing apps, is when you're on a website, you don't own the server. You're just a consumer of the website. When you're an app, you own the app being run. You have all the code at your fingertips. You own the system it's being run on. And all those combined means you can do anything, which means more and more applications have to do everything server side with the client or the app simply being nothing. It's just something that communicates with the server. You can see here with signature scheme v2, we're not going to talk much about it because the whole idea of this was saying signature is now a huge block signature, that it takes over the entire application, so you can't touch anything now. If you change even one file, it's going to fail signing and not work, which, once again, this is 7.0 only, or future. So we'll see maybe whatever comes out after Android P, Pumpkin Spice, whoever. We'll see what happens. As we get into the future, more and more applications should start doing this and increase security. Then I want to talk about safety net. This is a pretty crazy one, and I keep looking up here, and this looks crazy from my angle. I hope from your side it doesn't look that stretched, but it's me. Never had a Mac before, so I'm trying to learn how this stuff works. Safety net is something Google made to enforce the fact that the device you own is legitimate. It's available to run Google software. It's not modified in any way. This was made for two reasons. One, there's a lot of phones that that come out of like foreign worlds that aren't verified. I mean, there's literally malware in the system, and they sell them. It's pretty sad. They aren't verified to sell Google's, not sell, but to include the Google suite of apps, and they fail safety net. So this thing does that in addition to detecting if you're an emulator, if you're a root, if you're running exposed or anything like that, and says, hey, I'm not going to let you use Android Pay, so don't try. I think Netflix uses it now. Anything that's bank related uses it, and there's probably a few games that use it as well. So we hit this cat chasing mouse race where new applications started launching. Magic Mask is a big one, and Root Switch. And these were things that were systemless, which means they don't touch your system, and they have the ability to trick the system into what is going on. So the system reaches out and says, hey, are you rooted? I'm looking for this file. Magic Mask intercepts it and says, no, it's not there. Well, it is. So it's a pretty powerful thing because you can lie to Google or the safety net. And it pairs with Expose. So once we are back again with Expose, which we just saw is used very powerfully for messing with apps, and we can do it without being detected by safety net. And also reset props. If you've ever looked at your build.prop file on your Android device, it has probably 100 things that explain your phone resolution, size, a bunch of random things. These can reset them to what they should be, so you can't be detected that you are actually a rooted device. So Google said, haha, you guys think you know what you're doing, but we own Google, so we are smarter. And they came out with Safety Net v2. This thing is very, very smart. It runs passively behind the scenes and actively when it's requested. And it has a huge module called Droid Guard. And when Safety Net v2 came out, it was the first time they actually minified and obfuscated their app. Prior to this, Safety Net was easy to view. You could decompile the Play Store and look at the module. Now you can't. And this is because Droid Guard is very smart. It does some crazy things where it intentionally throws an exception and then catches it and reads the stack trace, because if it sees exposed or something in the stack trace, it goes, oh, someone's intercepting exceptions, and it can detect it that way. It does this weird thing too where it does idle. If you're not even using an application, it wakes up and checks your device. So if you're one of those people that uses root switch, which allows to tell your device, I'm rooted or not, it's running even when you're not using it behind the scenes to detect, are you a legitimate device or not? But SafetyNet, besides what we saw here in Droid Guard, did launch reCAPTCHA. And reCAPTCHA now, if you've never noticed, doesn't actually ask you to input anything anymore. You literally just click a button. And what's going on behind the scenes is huge machine learning JavaScript checks and checking too many things that I can't pretend to understand. And this paired with safe browsing is this huge neural network of things saying, hey, I know what's safe out there and what isn't. You shouldn't be going there. And the last point here is the Zygote inspection, which if you don't know Android at the very low level, right when it boots is this little process called Zygote. I hope I'm pronouncing it right. I've never heard anyone say it yet, so I hope I am. It says an application launches and says, hey, I want access to the radio, hey, I want access to something, and it delivers it. So you have control over the system. But if you control the phone, you can control this. So people started hooking such a low-level process with a tool called, we looked at it briefly, Magic Mask, and Chainfire, who makes the popular rooting things, made one called SU Hide, which messes with Zygote at this low level. So the system has no idea what's going on because the system is lying. So it's a never-ending battle. SafetyNet is tough. You might pass it after doing some crazy things with Magic Mask, but then 3 days from now you're going to fail because Magic Mask updates like the Play Store. When have you ever seen your Play Store update? It probably updates when you've never caught it. Maybe you've seen the notification, but point being, it updates as fast and as without you knowing. It's constantly evolving. So I said it again, it's a cat and mouse game. We just talked about SSU Hide, and I did mention Root Switch. Root Switch is an amazing one because paired with Magic Mask, you can say, hey, I don't want to be rooted for this game, but I want to be rooted for this game. And it's smart enough to do it. Systemless Exposed is really the only way to install Exposed in this day and age because if you install it to your system, you're immediately going to fail SafetyNet. And what fun is a phone if you can't use Netflix, bank apps, any of the games that are using it now? Your systemless is the only option. We're almost done with this talk here. Blew through it, but Android 8.0 just came out, or not really just came out, but it's pretty new, and they have some pretty sweet fixes here. The one that I mentioned really early on in the talk was how Android ID became tweaked. But going in order, SSL downgrading attacks, I don't know if you've watched, or these weren't in the news, you would have to read them, but a lot of times attackers have been tricking servers to communicate at a lower SSL or TLS level than they should. Because if you're a client, you can just say, hey, I don't have the newest security thing, can you talk to me on this old one? And the server says, okay, sure, I'll talk to you on this old insecure protocol, let's do it. So Android now is not going to allow you to do that. I don't know how many people this actually affects. I don't think there's many legitimate reasons. If you're not serving the newest TLS, you're probably not in the business that you should be. So I don't care if that broke anyone's stuff, they needed it. Android ID, we talked about in the beginning how Snapchat, because they used Android ID, which is the same for every app, allowed them to have images decoded. Now that's not the case. You can go read the docs on this for Oreo, but the gist of it is per user, per app, it's different. It's crazy smart. If you upgrade your Android device, it's still going to be the same unless you upgrade it through an unofficial means. So if you're someone that uses this as a unique ID in some database, bad idea. It's about to change a lot, so not a good idea to use that. Then we saw the verified boot system, which this is entering DRM territory, so it's a bit scary. It basically means that our device is not going to boot if it sees unsigned code, which that kind of already is there everywhere with most devices. For some like the Pixel, you run one command, I think it's ADB OEM unlock, and you're good to go. But some of these things are saying, hey, regardless of these things, we're not going to boot your device if you have an unsigned module or exposed or something there. And Oreo badly broke exposed, which if you see the pattern here, Android 7 didn't get exposed working until 3-4 weeks ago, and it came out, I don't even remember when 7.0 came out, but it's taking app developers a long time to produce something working on the newest Android, and by the time they do, the next one's out. I know this is a problem because I have like 80 tickets left in my APK tool repository, and I'm one guy with little time, so it's stressful. They keep breaking things, and it's too much work to fix them. So closing up here, as I went pretty quickly through this, is one thing I can't say enough is you can't trust the client. They say that when you do web development, but in the mobile world, it's very serious. It's not even you can't trust the client, you can't trust anything. They can change your app. They can change the system which the app runs. So you have to move everything you thought about if you're doing secret logic and embedding secret codes away from the app. A lot of applications these days, those top 10, 15 ones, are working entirely in native libraries, because if you work in a native library, you get the benefit of obfuscating native code is actually a lot easier than Java code, because no matter how many times you mess with Java code, if you're using like ProGuard or DexGuard, it's still Java code. So you can still look at it. Native, however, if you do a good job at native obfuscation, it's hard to do. It can detect debuggers and reject you. It can take a simple login method to 16,000 methods. It's too much work. SSL is a requirement. My other point, we're in 2017. I think I heard the Mozilla security talk today say that. There's no reason to not have SSL now. If you're starting something new, it's a must. And with Let's Encrypt giving it for free, there's really no reason not to. The next thing is crypto is tough. Don't reinvent it. I saw an application thought they were funny implementing their own RC4, which is like a very legacy cipher stream, but they changed it a bit. And if you change something, I don't think you know. There's people that spend their lives developing crypto standards. There's reasons for why there's only so many of them. So applications that do things custom are bad. It's too easy to break, and people don't know the problems they've written when they rolled their own crypto solution. And then finally, iterate and sunset old versions. This is a big thing, because if I were to launch the Snapchat version that launched 3 years ago on my phone, as I'm trying to log in, it's going to pop up and say, hey, you have to update. We're not going to let you sign in with this old version. And if you thought, oh, I'll just lie to the person and change the request outbound to say, hey, I'm the new version, that won't work either, because they're testing your application because you have to send a specific blob of text, which is only generated, et cetera. It's harder than it seems. So if you are an app developer out here and you have some API thing, I hope you can detect old from new, because as you update, the point is to kill off old versions. A lot of popular games do something where they force an upgrade, so you can stay on like 2 versions old, but then once you hit that 3rd version, that one in the past, you can't play anymore unless you update. And some people have the complaint, I can't update a 50 meg game every week. I think that's a ridiculous response. Unless you're living in some third world country where data is very expensive, I wouldn't expect you to be playing mobile games that are data intensive, so I think it's a bad argument. With that, I know everyone's pretty exhausted and tired, so that was it. We went pretty quick. Actually, I think we went perfectly, so as I'm looking at the time, but that was it. If anyone has any questions, they can stick around or talk or hands up, or if people want to escape out of here and go, you can do that. I'll just stand up here and for anyone that wants to chit chat or not.